Nielsen. I've been using Linux since at least 2000, maybe a little sooner. I know I've used FreeBSD for a little longer than that, 98 or so. Kind of partial to the BSD side, just full disclosure, but Linux has its uses, and I use it quite a bit at work, which I'm a systems engineer at Domo. So I don't write Domo code, but I write the managed infrastructure that it runs on. I do a lot of automation and scripting there. Tonight I was actually sponsored by my wife, who's watching the baby. So I'm going to talk about OpenVPN. Kind of just a lot of knowledge dumped on you. So if you have questions, I'd love for this to be a little bit of a discussion. I don't have a rush to get through anything, but yeah, want to answer questions you have and talk about what's interesting to you guys. But yeah, let's just jump right in. So first of all, who's used OpenVPN before? Who's configured any sort of VPN before? Who has what they say, a decent networking knowledge foundation? Close enough. All right. So I'm assuming you have at least some networking background and kind of know what a VPN is. We're going to answer that question briefly just for completeness, but here we go. So OpenVPN kind of can do whatever you want, wherever you want. It's very flexible. I call it Swiss Army knife, a VPN software. VPN, in case you forgot, is a virtual private network, which is just an encrypted tunnel between two sites or between a server and multiple clients. And hosts on either end of the tunnel communicate securely and easily with each other. You don't have to worry about setting up the connection once the tunnel is established. It just passes traffic back and forth transparently. A site, in this definition, can be a single host on either side, or it can be a large organization on either side, or a single host connecting to a LAN or anything in between. Other VPNs you may have heard of: point-to-point tunneling protocol, kind of the old one that came with Windows. Layer 2 tunneling protocol has its uses in different places. IPsec, there are kind of a lot of different VPNs built using IPsec, but it kind of gives you the foundational security aspects more or less built into the IP protocol once you get everything set up, which is kind of painful. And then a whole bunch of proprietary ones. Cisco has AnyConnect. Can't even think of the names of the other firewall vendors right now, but quite a few out there. So what's VPN good for? A lot of things. The typical use case is remote access to some private network somewhere you're not. So your home, your office, the cloud. If you want to work remotely and you're not in the office but want to connect to office resources, if you have an office VPN, that'll allow you to get to those. Maybe you have a home media server. You want to listen to your music when you're on the road. If you set up your own VPN, you could do that pretty easily. You could link a virtual private cloud network to an office network, or two different office networks to each other. And more near to my heart is this one. You can fix the internet wherever you go if you have a good VPN server somewhere. If you're in a hotel, they have a firewall. They assume they know what you want to do, and they're wrong because you're a Linux guy and you're not just surfing the web all the time. Maybe they're blocking SSH or VNC, or maybe you want to play a game. Doesn't work. It could be a conference center, not a hotel. All kinds of actually guest networks are arbitrarily restrictive. You get on a VPN, you can route all your stuff through VPN, and suddenly you're bypassing the firewall and able to set your own rules on what you can get to. Yeah?
What ports I know a little bit about it, but obviously they're like blocking something, so they were blocking VPN in particular, or do you
yes.
like HTTP or something?
Yes and no. So, wow, that's a few slides down, but I'm going to talk about which port to use in particular, because it is one of the fun things about OpenVPN that actually makes it easier to get around certain firewalls. My personal favorite is to use port 443, because it's just HTTPS, and if you block that, nobody can do anything on the web. And it's difficult to distinguish an encrypted VPN packet from an encrypted web packet. There are other ports that are often open, but it's pretty trivial to see that it's not, for example, DNS if you use port 53. But we'll come back to that. So maybe you've got a work service or some other server that has a whitelist that allows your IP from your house to get to this resource, but you can't get to it from wherever you are. If you VPN through your house, you've got that IP suddenly. Or if you're in Canada and you want to watch Netflix, and not just what they show to Canadian subscribers, then you need to change your IP, which you can use a VPN for as well. I talked to someone from OpenVPN. She said they discourage actually using that, but I didn't take it to heart, I'm going to be honest. Another fun example, I actually don't live in Provo, I live in Orem. My dad lives in Provo, he has Google Fiber, he has the TV package. So both to help troubleshoot occasional issues, because he's not very savvy. Maybe I'll get him on Ubuntu, I don't know. Or to watch TV on the rare instances when I want to, because I don't actually have cable in my house. I did a layer 2 VPN from my house to my dad's house with its own wireless network. Put the phone and the tablet on the wireless network, get DHCP from Google Fiber. I can stream the Google Fiber from my dad's house. That's a VPN. So why OpenVPN in particular? It's open source, available anywhere, Linux, BSD, Mac, Windows. If you're on a Mac, I highly recommend using TunnelBlick, which is, I believe, a Google project. Just a nice wrapper around OpenVPN software. You can still edit your config files manually and do everything you need to, but it's pretty seamless. Windows, there's a OpenVPN client that has its own GUI aspects and a service. iPhone, Android, you name it, it's open source. If you want to port it to something else, you can port it to something else. And it's highly configurable. So that Swiss Army knife aspect, if you want to change the port, if you want to change the protocol, if you want to use compression, if you want to use a different encryption algorithm, all of that is available if you want. If you just want to have a simple basic thing, then it's like a 4-line config file, and off you go. It's just TCP or UDP. So unlike a lot of other VPN protocols, some of them use generic routing encapsulation, some of them use IP and IP. Those are different IP layer protocols than TCP or UDP. So if you have a dumb router or NAT device at your house or wherever you happen to be, it might not forward those, it might not know how to handle them properly or allow you to pass them through, but you've got to do TCP, you've got to do UDP, and that's all OpenVPN is, just those vanilla layer 3 protocols. So how does it work? You run OpenVPN on one side, you run it on the other side. If you're using TCP, the client connects to the server. If you're using UDP, it's kind of fuzzy which is which, and it doesn't actually matter very much unless you want it to. But they connect to each other, they authenticate to each other, or the client to the server at the very least. There's a virtual network interface, either a tunnel device or a tap device. We'll talk more about that in a second. Created on each endpoint. Once the authentication happens, the network interface is brought up and configured, and then the tunnel's up and running. Anything that goes to that interface gets encrypted and sent over the tunnel. Anything that's received over the tunnel gets decrypted and sent to the local networking stack. And I thought I had a diagram and couldn't find it when I was belatedly putting my slides together after a terrible week last week of everyone being sick. But it's, if you visualize, a packet with the payload, and then there's maybe TCP information, and then a MAC address, and that whole packet gets another, header wrapped around it with additional IP information. So there's an outer and inner header and addresses. And then the outer one is what's sent on the non-tunneled network, usually the internet. And the inner is what only the endpoints see, or things on either side of the tunnel. And the way you send things across the tunnel, because it's just, it looks and acts like an interface on your machine, is you just add a route. So if it's just a local, only the two hosts talking to each other, then there's automatically a route for the opposite side added when you create the IP address on the tunnel. If you want to say, hey, this is my whole corporate network, and I've got a client connecting, when the client connects, you can push a route from this corporate side and say, hey, the 10. 5.0. Whatever network should be routed over the tunnel so you can get to it. Yeah, is that clear-ish? I'm kind of rushing through that. So the network topology is, again, very flexible. It totally depends on what you're trying to do. But that's kind of the first thing to decide before you set up any configuration. The simplest, again, is just two sites talking to each other over the internet, but they can share a virtual subnet and a secure tunnel, or it could be a whole network or set of networks on either side. And you'd add routing or things to make that work. You can install OpenVPN on both endpoints. Again, if it's a LAN case, you only need your network appliance box to run OpenVPN. Everybody else can just talk over their private network. You set up authentication, which is most frequently done with certificates, TLS and RSA style certificates. You do configuration, which we're going to spend most of the time talking about. You start it up. If it doesn't work, you test, you reconfigure, you watch the logs, repeat if needed. You can crank the logging way up, so it's actually not that hard to troubleshoot if something goes wrong. But most of what's interesting and potentially daunting about OpenVPN is actually setting up the config file, because it's just a text file. You can put whatever you want in it. You have to know what to put in it. There are lots of different examples, but again, depending on your use case, examples may or may not apply. So we're going to spend the next little bit talking about different configuration options and kind of some gotchas, at least in my experience, of decisions you might want to make before you start writing your configuration file. For example, do you want to use a tap interface or a ton interface? I don't remember why tap was called tap. Anybody want to jump in on that? Ton is just short for tunnel, but tap is more like it's a real virtual Ethernet interface. So obviously it's virtual, but it has a MAC address and can transport any protocol. You can add it to a bridge. You can use broadcast traffic on it. Tunnel interfaces are more kind of dedicated for VPN, but really just for IP traffic. There's no MAC address. There's no layer 2 at all. So it's a little bit more efficient, less overhead. You're not sending that extra layer 2 frame over the outer connection, but it only lets you do IP. It doesn't let you do interesting thing like bridging. So the watching Google cable use case would not work with a ton interface. It has to be a tap. And it doesn't support broadcast traffic.
The thing is like Android and things like that don't support tap.
Good point. Yeah, thank you. Android, for the recording, Android and iPhone clients don't support tap. They only support ton. But
Is ton easier to set up than tap significantly, or are they about the same?
they're about the same. For me, tap actually makes a little bit more sense. But they're both really easy. It's the thing I dislike, and it's not really a downside, it's just how it works with the ton interface, is that if you have a server and multiple clients, the server has its own IP for each client. So there's a pair of IPs for each connection in your pool. Whereas on a tap interface, if the server is even handling the IP address, which it doesn't have to, it just has one, and then everybody else has one, and they can all talk to each other using effectively ARP.
So they actually, for each pair with the ton interface, I think they have a slash. It would be a /30. So there's actually 4 IP addresses because they have like the network address and the broadcast address.
That's pretty common with tunneling protocols. I don't think that's actually required for. Like, I think you have a larger subnet and it'll just take 2 at a time off of it.
Okay.
In OpenVPN.
That's what I've seen with OpenVPN in the past.
But yeah, /30 would burn 4 IPs.
So basically, with the tap interface, you're on their network, and so you would, for example, ask for an IP address, and their DHCP server would give it to you, right?
Yeah.
So
yeah, and if you wanted or needed to use DHCP on the remote side, that's a great use case for tap. Just say, hey, the server adds it to a bridge, and it handles the connection to this client, and it knows that that client's MAC address goes over the tunnel. But as far as handing out an IP address, the OpenVPN server just says, well, here's a packet, put it on the bridge, it goes on the network, and then the DHCP server sees it, responds with a DHCP offer if it's configured to do so.
A tap interface behaves more like a switch, like a smart switch that would see traffic and say, oh, well, it knows through its ARP tables that this one is on the other side, so it'll just send it out.
Yes.
Whereas a tunnel interface is more of a routing.
Yeah, tunnel is more for routing. Tap, you can add to a bridge, which then becomes a lot like a switch, because it's an Ethernet-like interface. And yeah, it handles ARP and all that. So other comments on that? So a related decision you're going to want to make pretty early on is, are you planning on routing through the OpenVPN endpoints, or are you just going to throw a tap interface in a bridge and let your existing routes do what they do? So we talked about the DHCP example. You sure want a bridge if you need to use a DHCP server that's not on your OpenVPN server endpoint. Or again, if you have any kind of broadcast traffic, Windows file sharing, certain various applications assume that broadcast traffic works. Or if routing isn't going to work for you, if your VPN server is not also your default gateway, and you can't modify the routes in other places, and you want those other nodes to be able to talk to your VPN clients and vice versa, if you can't add the routes, then you're going to have to get a bridge to get them there. Routing, though, is kind of the traditional way. The default for OpenVPN is to use ton, although it's just a one-line change to change it. A little bit less overhead, again, with not worrying about the MAC address, but just something to think about up front. I'm lazy, so my kind of existing configs use tap and bridges, so I just kind of use it everywhere. I'm not that concerned about the overhead of the Ethernet frame, but different people have different opinions. UDP versus TCP. This is not talking about what can go over the tunnel or what you can use a VPN with. This is talking about the outside connection, the outer packet transport. So if you're going over the internet, what actually goes over the internet is a UDP packet that contains your VPN payload, or a TCP packet that contains your VPN payload. Again, some pros and cons. UDP is the default for OpenVPN, and given it's a little bit more efficient because there's not the session tracking. And I think the rationale for it being the default is, well, if your protocols care about state and retransmission, then your inner protocol should take care of that. And that works fine. If you've got a VPN connection that's UDP on the outside, and you do a TCP connection over that link, the TCP will do the retransmission. You're not going to drop packets on your TCP link. If you're doing streaming and UDP over UDP, and you happen to drop packets, well, you're not going to miss the old ones because you're trying to keep up. So it's not that big a deal. TCP, again, is strongly client-server. There's got to be one side listening, one side connecting. It does the retransmission in the outer protocol, but the inner protocol doesn't know that. So it also does retransmission if you're using TCP over TCP. And that can cause some really weird timings in the scaling windows. So if you get things rebroadcast, retransmitted twice, it can just make things slow down. On modern links, it's not that big a deal unless you've got kind of a flaky wireless link, because packet loss is not as commonplace as it once was. So the main consideration for this would be if you're trying to get through a firewall and want to use port 443, that's going to be TCP. If you don't care, just use the default UDP on the default port, which happens to be 1194. Oh, there it is, ports. So out of the box, if you don't specify anything, OpenVPN is going to use a ton device. It's going to be using UDP for the outer protocol, and it's going to use UDP port 1194. That's a registered port with IANA. So if someone monitoring a network and wanting to know what everything is, we'll be able to classify it. If you have control over everything, then you might as well use the real correct port. SE Linux also knows what it is, and you don't need to make an exception for running the wrong protocol on a different port if you have SE Linux enabled on one of your endpoints. My favorite for a lot of scenarios, getting through the firewall example, is TCP 443. It's encrypted traffic on a port that's supposed to have encrypted traffic on it, and it's one that's open pretty much anywhere. So, yeah, if you need to get out and modify or have different firewall rules, then that's a good choice. One drawback, of course, is you can't run a web server on the same IP unless you do something like run SSL-H, which I learned about on Plug a few months ago. Thanks whoever posted that. But if you've got another IP or don't need a web server, then that's not a big deal. My other frequent choice is UDP 53, just because, again, it's UDP, which is the default, a little bit more streamlined and friendly to OpenVPN. Also open on a lot of firewalls. But if your firewall or other traffic intrusion or intrusion detection system has any kind of brains whatsoever, one look at the packet tells you it's not a DNS packet, because DNS packets are really simple and easy to inspect, and they're usually not full frame size either. So a smart firewall will still block that if it's expecting and enforcing only DNS traffic on port 53, but it's an option. UDP 123 I used just for fun. I can't remember why. NTP, but again, it doesn't look like NTP. It just happens to be open sometimes. Really, though, it doesn't matter. If you want to pick a different port, go for it. Just remember to tell SE Linux about it. And if you're running multiple instances of OpenVPN, which it's easy to do, there's no reason you can't. Each one gets its own TON or TAP interface. They are going to need their own port per instance. So I've seen places do 1195, 1196, where it just kind of increment them or decrement them. But it doesn't matter. Just put it in the config file. Make sure it gets through the firewalls and SE Linux, and you're fine.
Can I ask one question?
Please.
Sorry, I'm more of a math guy than a computer guy, so this may sound stupid. But is UDP not allowed over port 443?
It is. I mean, TCP and UDP both use ports that are 16 bits, so up to 65,000. But TCP 443 has a special meaning of this is a secure web server.
Right.
UDP 443 does not have that special meaning, so it's not as likely to be allowed through a firewall.
Oh, okay. So like the rule itself would be not only is this port open, but I only allow TCP packets through this port.
Yes.
Like if you're on a hotel or conference network that has very locked down firewall, they'll only allow
Port 80
certain ports out.
And
So-
packet types on that port.
Right, so it'll be TCP 443 will be allowed out, but they'd have no reason to allow UDP out on that port. So.
Yeah, and from a network hierarchy standpoint, you look at the protocol before you look at the port. So if you say, hey, this is port UDP, I'm going to look at my UDP rules, which might include port numbers. Or hey, this is TCP, I'm going to look at my TCP rules, which might include port numbers. They're totally separate.
Okay.
Good question. All right, IP address management for your endpoint. So this is within the VPN tunnel. Again, depends on what you're trying to do, network topology. First rule is try not to cause a conflict. You almost always are going to want to use a private RFC 1918 IP address, so 10. Whatever, or 192.168, whatever. You can do them statically. If you have a DHCP server and you're using a bridge with a tap interface, you might not have to worry about it. Just throw it in the bridge and the client's got DHCP leases. Or the server, if your OpenVPN server can maintain a pool of IP addresses and allocate those as needed. Or again, you can just do them statically. I'm going to show you a couple examples of configurations that include both of these. But really, it just kind of depends on your overall network policy and what's available. You can do a lot more network stuff, both within and kind of outside or alongside of OpenVPN. You can add a route when the tunnel's brought up, or more than one. You can specify DNS servers to use for the tunnel, and you can push both of those from one side of the tunnel to the other. So you have a server, a client connecting to the server. It not only gets an IP address, but it gets, hey, here's a list of routes you should use of what to send over this tunnel, and here's the DNS servers you should use, and a couple other things like that. If that doesn't meet your needs, the stuff that's built in that you can do in the config file, you can write your own script that gets run every time the tunnel comes up, or you can write one that does come when it comes down as well.
Those can be ignored by the client as well.
Yes. Yeah, so it's totally configurable. You can configure the client to not accept things from the other side if you want. That's a good point. Yeah, I've actually done that before. I'm not going to talk much about helper scripts, but it gives you all the information you need, as far as IP addresses and routes to know what's going on. So if you do have something special you need to authenticate, or do something weird with your DNS, or do a different route that's actually not across the tunnel, you can do all that kind of things in a script. Authentication, a few different ways to do it. This is actually not an exhaustive list. It's not required, first of all, in OpenVPN. You can say, hey, here's a tunnel. If I'm a server and anyone can connect to me, or I'm a peer and I'm going to talk to this other peer with this IP with no authentication, that'll work. Don't do it. You'll get hacked, or in trouble, or just should feel bad your own self because you're making the internet a less secure place. Pre-shared key is actually really easy if you don't want to deal with the TLS certificates, which I'm going to show you is not that hard. But there's a one-liner. You can generate a key. You copy the key file from one endpoint to the other, and then they both point to the pre-shared key. There's your authentication. Trivial to do, but it doesn't really scale well, and you don't really know anything about who's connecting to you other than they have the key. It's right. So if you want to do any kind of per-client connection, you need to know what the client is, and that's something you don't get with pre-shared key. TLS certificates are, I don't want to say the default because you have to configure them, but they're the de facto standard for OpenVPN authentication. And it's not like you have to go out and register a certificate and pay someone to sign it. You can use your own certificate authority, most people do. And it can be just for OpenVPN, or you can use the same certificates you use in your existing public key infrastructure for your organization. The nice thing about keys is each person has their own, or each client has their own. You can revoke them, so you can maintain a certificate revocation list on the OpenVPN server. You know who's connecting to you. There's a common name, which can be whatever you want. It can be John, it can be client one, it can be a fully qualified domain name. But when you connect to the OpenVPN server, it sees that and it treats that as a unique identifier for that client. Someone else connecting with the same key will by default disconnect a prior connection using that key, because they're assuming there's only one person that should be connecting with that key, and they must have lost their connection, so I'm going to use the second one and kill the first one. You can disable that if you have a reason to share keys, but the whole point is not to. And again, EasyRSA makes it trivial. I'm going to show you in the last 5 minutes how you can set up your own certificates. But they're really simple. We're going to look at a few configs, because again, that's kind of, you can install the software and talk about the concepts, but actually doing it, you've got to know what to put in the config file in most cases. This is pretty much trivial here. We've got two hosts. Host A trying to connect to host B. We're not doing any routing. They're just wanting to share this tunnel between themselves. Remote says, all right, I'm going to talk to somebody else on the network that has this IP or host name. These are made up. They don't resolve. But they, frequently a public IP address. And in this kind of peer-to-peer scenario, there's not really a client or server, so each side has a remote directive. So it doesn't matter which one starts first. They're just going to try and talk to each other. ifconfig is what it sounds like if you're familiar with the Linux command. we're going to configure the interface, in this case the tunnel interface, to have this IP address on the local side. And since it's a tunnel interface, we also need to specify a remote IP address for the far side. So I'm using the class B RSA 1918 address space, but just saying 2.1 for host A and 2.2 for host B. Notice it's reversed on the other side. So host B, hey, I'm 2.2, and I'm talking to 2.1. Using a pre-shared key, so just path to key file, or if it's in the OpenVPN config directory, you don't even need the path, just say key file. Specified protocol is UDP, port 1194, dev type is ton. Those are all default, so if you want to comment them out, it won't change the behavior at all. But I like to spell it out so I know exactly what I'm doing. And this will work fine if there's no firewall, and these are actual hosts. Then they'll come up. You'll start it. You'll be able to ping from host A. You'll be able to ping 2.2. From host B, you'll be able to ping 2.1, and that traffic will be encrypted. Again, without routing any other traffic, it's not maybe that useful, but as a starting point, and when you're struggling with troubleshooting something or doing something new, it's nice to get something working and see that it's working. So this is that kind of starting point. Comments on that? And the only prep you need to do for that is generate the key and share it. So OpenVPN will generate a key for you if you don't have another way to do it. OpenVPN gen key with shared secret, save it in a file, copy the file to the other server. You're done. A little more involved config. We're going to come back to this and do it as a demo at the end. We're using TCP as the outer protocol. We're using tap interface instead of ton. We're using TLS certificates instead of a pre-shared key. And there might be a couple other goodies in here as well. Also using these shortcut directives, server and client. If you look at the OpenVPN man page, which is actually pretty good, it'll tell you that server actually expands out to this list of directives. It says, yeah, I'm going to maintain an IP pool for this range, and I'm the TLS server, and I'm accepting TCP connections, and all that kind of stuff. And conversely, we have a client, which similarly expands out to a few directives for OpenVPN's internal parsing. But it makes it easier to read and saves you some typing. I would recommend reading over the man page for any time you're doing a config. Just look up, make sure that there aren't any gotchas about the directives you're using. So this is a shorthand for saying I want a pool of IPs. The server's going to manage it. It's going to hand them out to the clients. Here's the network address. Here's the subnet mask. So it's the /24 10.3.6. So anybody that connects, first of all, I'm going to be 10.3.6.1. That's implied in this server directive. And anybody else is going to be in the range 10.3.6.2 through 10.3.6.254. TCP server port 443, so we're doing the HTTPS firewall bypass, hopefully. Local directive is kind of the opposite of the we had before, the remote. It just says on this side, what IP should I use? If you've got a multi-homed host with a bunch of IP addresses, you might not want it, sourcing things from all of them. Maybe there's a specific IP you want it to use. Dev tap, so we're going to use a full Ethernet style tap interface. Verb is verbosity, so how much stuff goes to the log. It's pretty useful for troubleshooting. 3 is a good middle of the road kind of number. And then these 4 and 3 on the other side are just for the certificates. So these are files, they already exist, you've created them. There's a certificate authority certificate. There's a key and a certificate for the server. There's a Diffie-Hellman parameters cert file for the server. And the client just has the certificate authority and its key and certificate. Client to client means if there's more than one client, they can talk to each other. The VPN server will kind of handle that routing, depending on how the network looks like. It could be routing or bridging, but it's just forwarding. Keep alive means try not to let the connection go dead. Send a keep alive packet every 30 seconds, and if you haven't gotten one from the other side after 10 minutes, hang up and try and reconnect. Comp LZO is actually deprecated. It means use compression. LZO is a lightweight compression algorithm. So just try and make outside packets a little smaller as they go over the wire. The client is simpler, but very similar. L port just means, hey, even though I'm using 443 on the far side, I'm going to use the default 1194 on the client side, so that's shorthand for local port. If you don't specify that, it defaults to whatever port you're using on the remote side. And then instead of local IP, I have remote with the same IP because that's where my TCP server is listening, and the same similar certificate kind of options. This redirect gateway one for the hotel use case is a good one. Older versions of OpenVPN, you had to do some routing manually, either change the default route or add other routes that added up to the default route without locking yourself out or keeping yourself from talking to the VPN endpoint and still being able to talk to things like the DHCP server or your DNS servers. This redirect gateway handles most of that for you. With a couple caveats, you should still be wary of killing the route you're using for your outer tunnel to connect.
So in this example, are you self-signing your own TLS certificates in this case?
Yes.
Okay. And does OpenVPN have built-in tools to generate those certificates for you, or do you have to use something?
They recommend and frequently ship with a package called EasyRSA,
Okay.
which I'll show you on the next slide. There's about 5 commands to get everything you need for that config.
Okay.
And again, we're going to come back. We're going to actually demonstrate this as a change where you look like you're coming from on the internet and get through a local firewall to do that example. But as far as prepping, obviously you need to install OpenVPN. FreeBSD EasyRSA is actually a requirement for the package, or you can install it yourself on CentOS. Very similar on other distributions. And then the rest of this is just setting up the PKI. So make a directory for stuff to live in, change into it. Init PKI makes a subdirectory in here called PKI. Build-ca creates a certificate authority, prompts you for a password, puts the files in place, creates a certificate for said certificate authority. GenDH is for the Diffie-Hellman parameters, which won't mean anything to you if you're not a cryptography person, but it's just a file you need on the server side. Build server full creates a server style certificate and key. Build client full creates a client style certificate and key. And what I didn't put here is then from this side you need to copy, if this is the server side, you need to copy the certificate authority file, the client key, and the client certificate over to the other host. I actually do this backwards in the example, so this is the client, so I'm copying everything else to the host. But that's it, and this is documented pretty well in EasyRSA itself, as well as a bunch of different web pages. And I'll post the slides if you actually want to follow along that closely. One more config we're going to look through is a real-world place I used to work. They used OpenVPN for their Office official VPN. So they had a server running in the data center, which had a link to the Office network, and then clients just had their own certificates and config files. They could connect from a laptop wherever they could get to the internal mail server, internal DNS server, as well as look like they were on the internal LAN for talking to certain websites, which were whitelisted. Similar to the other one, we got server, port, proto, dev. This is all PKI stuff. CRL is a certificate revocation list. So what we didn't do in the last one is have the ability to fire someone and invalidate their certificate. This will do it. Say, hey, I'm going to check for this certificate revocation list. Things that are on there will not be considered valid, even if they're otherwise valid for the CA. Persisting the IP addresses, so you get the same IP the second time you connect as you did the first. Client config dir saves a little config file for each client who connects. The names of those files are the common name from the certificate that the client presents when he connects. And then I'll push some routes. I truncated to just one, but we used a 10/16 as the local LAN here, so push that out so you don't have to manually add the route on the client side when you connect. Push out a DNS server, which is on the LAN, so you can resolve those internal host names. Push out a domain for DNS, which was definitely not real-world.org, but we'll go with that. Client to client again. Some cases when a client might need to talk to another client machine, we allow that over this VPN. Keep live verbosity. And then because all these settings are pushed on the server side, the client is still pretty simple config. Explicitly say ton UDP. The remote endpoint is the main thing in there, plus the client directive, plus the path to the certificate. And this is different for each client because each client has their own certificate. So they're not going to have Jay Nielsen's key. They'll have their own. I guess we can make the file name the same, but that'd be a little more confusing. That's that. So on CentOS, it's pretty nice with systemd. You install OpenVPN. There's an etc OpenVPN directory. You can drop your config files in there. You can drop your keys in there. And you just use this @ notation because it supports multiple instances. So if you have a myVPN config file, you can systemctl enable OpenVPN @ myVPN, and starting that service will run OpenVPN with that config file. Similar facilities, I believe, exist on Ubuntu and other distros. Questions? We're going to jump into a demo and go back to the second config I talked about. And before that, all right. Okay, that is much too small. Oops. So I'm cheating a little bit. I'm not actually going to copy the files around, but I am going to generate all of the keys. So this in the screen session, I've just got a shell on each endpoint. One is a VM running at my house named Monster. It's got a private internal NAT IP, no public IP. And the other is a FreeBSD box on the public internet, also VM on a cloud provider, which has a couple of public IPs. Has to be running FreeBSD. So on the CentOS side, we're going to install OpenVPN and EasyRSA. We're going to cheat and copy paste those over, making ourselves a PKI directory, which is empty. And then EasyRSA build CA. We're going to create a certificate authority. Don't forget this passphrase. Even if you don't put passwords on your certificates, you need a password for your CA. You're going to help me remember this is password with a capital P, which I don't recommend. Common name is what you're calling this. CA, we'll do John, demo, CA, and we're done. So far, we've got this PKI directory generated by init PKI. We've got a certificate authority key, and we've got some directories and an index, and the certificate authority certificate, which we'll copy around to things that need to verify our certs. GenDH gives us a lovely Diffie-Hellman parameters file, 2048-bit. Used to take a long time, not so much on a modern CPU. And that tells us again, we've got a Diffie-Hellman file. Now we're going to create a certificate named server with no password. Even though I said no password, I still need to do the certificate authority password. And there it is. Common name is just server. Certificate is valid for 10 years. I was really annoyed after the first time I was playing with certificates and 10 years went by and I had to redo them all. But you can edit that. It's a good idea to redo them once in a while, though. So now we've got a bunch more stuff in here. We did a certificate sign request and signed the certificate just in the EasyRSA script, as well as the actual server key. Oops, where's client key in there? Oh. That's my cheating stash from when I did it before. Server certificate and server key, as well as these indexes. We build the client one, same thing. It's just going to be named client 1 with no password. I need the CA password. And now I've got certs for those. So on the other side, in addition to copying the certificate files around, this is FreeBSD, so I'm just going to use PKG. We also got EasyRSA and LZ4. Now we just copy some files around. On the RSA machine, which in this case is going to be my client, I have the certificate authority certificate, the client certificate, client key, and a config file, which we'll look at in a moment. On the server, I have the same certificate authority certificate, the Diffie-Hellman file, and the server's client, or certificate and key. As far as config goes, this is almost identical to what we showed on this slide, which I can't get to now. Up here. So I'm going to be using this short server directive. I've got an IP pool /24. I'm going to use persistent IP addresses, TCP port 443. I have an actual public IP with a DNS name for my local server. There's their certificate stuff. That's about it. So let's start that up. Actually, no, not yet. On the client here, again, very similar to what we had over here. Using TAP, we're connecting to this public IP, using the client key, so on. So I'm starting up the server, OpenVPN server on the server side, and we're going to watch the logs. It's done. Tells us we're using tap 0. It assigned it a local IP. We've got a pool and an initialization sequence completed. On the server side, or sorry, the client side, we're gonna systemctl enable OpenVPN at demo, which is what I called the config file, and then just start it. And see how it's doing. Looks happy, connected, config. There's the public IP. Here's a private IP on the tunnel. And additional messages on the server side tell us much the same thing. We got a client connected. TLS verified OK. Some debugging info about the peer. And IP stuff. Thank you, NetHack messages and screen. So we're good. Now I've got a tap device on my client. It's got 10.3.6.2 on the server. We've got a tap device. It's got 10.3.6.1. Can ping across the tunnel. It takes twice as long the first time because ARP is going across because I'm using tap devices. And then I got 20 seconds from California to Utah. 20 milliseconds, excuse me. Now the other fun thing, so I didn't do any routing with this. So the client just has the original default route, which is local, the network route for the VPN subnet, and that's it. If we change that and stop it, edit the demo conf, and I'm just gonna do this redirect gateway directive. Def1 is, it splits up the default route into two, so you don't actually have to kill your original default route. And then we're just going to start it again. Actually, no, let me do that. So when I'm not on the VPN, I can do trace route to Google, which goes to Xmission and Google via Slicks. I can do a dig command to OpenDNS to ask it what my public IP is, which is my home IP, which I call stealth. So now I'm going to connect the VPN. Give it a hot second. Run that same command, see what my public IP is. And notice that it ends in 172 now, instead of 122, which is my, if I could spell it, my VPN server. Trace route from here now goes all over the place, but it's coming out of San Jose instead of Slicks. So I can not very impressive from a terminal, but I can go to websites and actually I'm coming from my VPN server instead of my IP address at home. You do need on your VPN server for that to work to have NAT enabled, which is just a one-liner with IP tables. If you're on a Linux server, a FreeBSD box, it's a 2-liner. And so I'm actually adding stuff to and from the private VPN address. So working VPN. So again, kind of a dump. Anything else you want to see? Any questions? Go
You
ahead.
said that you could bring it to your local network so that you use your local network's DHCP. How would you do that?
Yes. So in this example, it's kind of backwards because I don't have a DHCP server on my VPN server. I'm trying to think there. I'm not sure there's a built-in way in the OpenVPN config file to add it to the bridge. But what you do on the OpenVPN side is don't have an IP config. The server doesn't have an IP pool. The client doesn't have an IF config. The server might have an IP on that network already. So that's what you create a bridge interface on the server side, assign the IP to that, add the LAN interface to that bridge. So instead of having the IP address for the LAN directly on the LAN interface, you have it on the bridge, and then add the LAN to that bridge. If it's the only thing in the bridge, it works the same. But then in a up script for OpenVPN, when a tunnel comes up, or when you actually, you don't need to do that. It's just as soon as you start the OpenVPN service, or before, you add the specified tap interface to the bridge, and then you run your server, and you're good to go. Clients connect, they don't on the server side. So client connects, authentication happens, the tunnel's up, we've got 2 tap interfaces connected with no IP addresses directly on them. This tap interface is in a bridge, and this tap interface, you probably then want to do an up script on the client side to run DH client tap 0, for example, which would do a broadcast. It would go across the tunnel. The server would come in on the tap, get decrypted, go out through the bridge, go out on the LAN interface, hit the DHCP server, get the offer, and then away you go. Hope that makes sense. Anything else? All right, again, I will post the slides. I'll put the link on the mailing list. They're not up yet. And feel free to email me any questions that do come up. Thanks.